Hey, hello everyone. Welcome to your very own class 9th and 10th channel. And yes, today we are going to learn about image formation by spherical lenses. Now before I start, let me welcome you all. I can see some new faces, a few old faces. Yes, I can see only An and Aksh right now actually. Yes, and Ashi. Hey, hello everyone. How are you? Let me ask you, am I clearly audible and visible to you? Thank you, Disha. Yes. Hello, hey, yes. So, before this, how many of you have seen the previous sessions? One question. How many of you have seen the previous session? Yes. Hey, Mitraj, कोई बात नहीं, हो जाएगा. Right? Okay. Arush says yes. Muskan. Nice. You have seen it. Means that's better. Because the reason is lens is very much connected with mirrors. See, I want to just mention this again. Academically, lens or light ka chapter, it might be difficult. You might feel it is difficult. But you know what? If you are attentive in all the sessions, let me tell you, this chapter will be very easy for you. We'll do all the practice numericals, we'll do all the concept sessions, right? Everything will do very nicely. It's just you need to be regular and attentive. That's important, hai na? Thank you, Disha. Yes, so that's why. Let's start understanding lenses. People who feel lenses are difficult, hold on. This session is especially for you. So focus, pay attention, and it's okay. Physics is not tough, I would say. Physics is very easy if you start feeling it, imagining it, understanding it. ठीक है? आज वही करेंगे. Nice, Disha. Very good. Arey, you are a senior, you would know. Right? So that's why. Let's start this. And the 45 days plan is still on, and we are almost near completion of light chapter. Okay? Yes? Nice, huh? Even if you miss, I understand, see, you guys have now schools, homeworks, and a lot of things. Even if you miss, I would say watch the recordings. Watch the session which has gone live because it stays on the channel. Hai? Don't miss it. And before you come to the next session, do it. Now that all of you are saying, hello, Sath, you're not late. Now that all of you are saying that you have watched the previous sessions, do you remember in one of the session, like last to last session, this was a homework question given. Disha, conceptually it's over. Yes. Thank you, Preetham. Nice, Harush. So, how many of you remember that this was one homework question given to you in last to last session? But you know what? I was amazed to see there was no reply. I mean, there was no comment. No one tried this, huh? Did anyone try this? Yes. See, actually today I was going to do it in the live session, but now I'm thinking if you haven't tried it, should I do it? I'm not sure. Should I do it? It was not seen, huh? So you might know what will happen, but my question is, did you try it yourself? Because see, I'm telling you, a lot of things we read, a lot of things we study, but reading and studying is different. When you try it yourself, that is a different feeling, right? Correct? Anna? So that's why today's actually I was not thinking to do it. What do you say? Should I do it? Because I'm thinking there was no comment here. I was so surprised to see it. What do you say? Should we do it or should we leave it for the next session? Yes, Disha. You will try, huh? Okay. ठीक है, all right. See, now that you are saying that you'll try, let me give you the mark 1. What do we say, mark 1? All right, ठीक है, I won't do it, but I'll show you what you will see. All right. I'll show you what you will see, because if I tell you the truth, I brought all the things. See, I brought a bottle, I brought the piece also, I brought water also. I was thinking to do it, but it's okay. I'll leave it for the next session. Hey Niva, Not. You're not late. It's okay. So, I'll but show you what will you see. Okay? Nice. Very good, Akansha. But you haven't commented, by the way. Right? So, okay, I'll show you what you will see. Watch. You will see something like this. You will see something like this. You will see letters will look big. They will look magnified. है ना? सुभाष 9th का concept खत्म हो गया है. Practice कहीं ना कहीं बचा हुआ है अभी, है ना? We have not done numericals. That I know. Don't worry, we'll do everything. हाँ, सस्ता magnifying lens है kind of. Yes, true. Right, that's why. This is a, what do I say, a very raw kind of magnifying lens. You can make it at your home very easily. You just have to cut a small piece from the bottle, the curved piece, fill water, and then you will see the letters magnified. Okay, nice. And it's very easy. The reason I gave it to you is it's very easy. But now that you have seen what this can do, curious fellow, nice. So the reason I asked you if you tried this is because the answer is lying in this session. You will see why the letters are magnified. Okay, yes, convex water lens, correct, right? So, but you know what, this, I would say, this is Mark 1 of your own magnifying lens. There is something called as Mark 2 also. And by the way, I have that. Not today, but I have tried that also. You can make your very own magnifying lens. You know what kind of magnifying lens? This kind of magnifying lens. This is like very nice, beautiful looking magnifying lens, no? But you can actually make something like this using water and plastic bottle only. Okay? Hey, Jagdishwar. Yes? It's, no, Niba, it's not concave. Yeah. You can cut it from the bottle surface, no? I have cut this from here. I'll show you. From here, this thing, this portion. So if you take it out, you have your convex lens. And if you take two of them and stick them with water inside, you will see a proper magnifying lens. Okay? So yes, that's why. How? Wait, right? Wait for this session. Let this session go. Okay, nice. So this is again a homework for you. Try this easy version, and then if you feel confident enough, go for the higher version, the Mark 2 of magnifying lens. And in next session, I'll bring it for you. Don't worry. Okay. Nice. All right. Cool. All right. Let's move forward then. So this was the homework question for last to last, but this one is for last session. And yes. So what I've noticed is, what kind of homework question do you like? So I want to ask this from you now that we are all here. What kind of homework questions do you like? Do you like questions which are straightforward answer, or the questions where you have to do something? Correct, Niba? You're right over there. Yes, Arush, true. Mind triggering questions, you know, yeah? Numericals. Numerical with theory. Alright. To do something, you know? Those actually, if you ask me personally, I like homework questions where you have to do something on your own and you can share your experiences, because that is something which I also really believe. Numericals ka kya hai? Numericals to you can do. I know you can do, right? Yes, nice. Okay. So I'll keep this in mind, by the way, na? So I'll give you such kind of homework questions. At least I'll try wherever possible, right? So this was last session's homework question, and I could see 3 people answering that. Chota Bheem, amazing artist, and Lakshit. So Lakshit, there was a small problem, but yeah, it was fine. Correct. So yes, congratulations everyone. Very good. And nice, very good, Ranjana. Alright, so let's start our session with magnifying glass. Right, let's start with magnifying glass. We all have seen magnifying glass, by the way, right? Somehow, at some point in your life, you have played with magnifying lens, right? Oh, Nibha, your question is between mirror and lens. It's not a mirror, it's a lens. So today we'll discuss about lenses. Mirrors you have already discussed. Now, if you have learned about mirrors, lenses become very easy for you. But if you have problems in mirrors, means lenses you will also struggle a little bit. So that's why I'm saying people who have not watched the previous sessions, because we have done a lot of things. We have done all the concepts. We have done few questions also. We have done tips and tricks to remember the positioning of images in concave mirrors, right? We have done all these things, okay? All right. So let's start with magnifying glass. What is a magnifying glass? And there's one more question to you. How many of you have shown this session, or how many of you have seen this session? We did one session, how to make a DIY projector at home. Do you remember this? Mitraj, I'm coming to this question, don't worry. Chalo, batao. Oh, nice, Prerna. Yes. You have seen, huh? Correct. Acha, if you have seen this, do you remember which lens did I use? Acha, Rishi, you haven't seen, huh? Go ahead. This was a very nice session. I mean, this was a very easy and nice projector, and I remember a lot of you have actually made it, and we also did a session on that. And I told you, people, if you send it to me again, good, nice, interesting DIYs, we'll make a session on that too. All right. Convex, very good. Nice, correct, Disha. It's the same. The thing which I'm holding is the same actually. And I actually used the same, this only in that, because if I remove this handle, no, it's removable. If I remove it, I actually used this only in that. So yeah, that was a convex lens also. So people who haven't seen this session, please see it. It was a very nice and a very interesting session in terms of something you can try. And this could be one of a nice science project you can actually make in your school. It'll be really cool, by the way. I'm telling you. Okay, go ahead and see it. Nice. All right. So you are saying it was a convex lens. So at least people who know or who don't know yet, there are two lenses, right? Convex and concave, because there were two mirrors also, convex and concave. Now, sir, the problem is I have convex concave mirror. Now I have convex concave lens. Oh, it is getting confusing now, sir. That's why. Hold on. Now, have you seen this crystal ball photography? People who like to click good images, who like photography a little bit, we somehow go for this kind of a thing, hai na? Right? It's okay, Disha. Hai na? So that's why we try to click this. Sometimes, let's say there is a raindrop like this, and you click picture from that raindrop, you get such kind of a thing. Hai na? You love photography? Nice. I also love photography. Prerna, oh nice. I'm thinking about that actually. Right? So this is another thing. So all these things, one thing is sure, these are not mirrors, because mirrors have shiny surface, polished, and you know what we see? We look into a mirror. But here what we are seeing the thing which is behind this thing, right? That's something which you are seeing. This crystal ball, you are able to see something which is behind that. But yes, it looks different. It looks distorted, it looks inverted, but you know what? One thing is sure, it's not a mirror, hai na? Correct? It's not a mirror. Fine. Then what is it? It's a lens, right? It's a lens, correct? Nice, Arush. Correct. So I'm coming to this. So let's talk about spherical lenses. So today you will notice that in whatever I explain, I'll keep matching the mirror and lens, spherical mirrors and spherical lenses. Okay? There is a good matching in between them, because then only you can remember everything. In physics, I'm telling you, light chapter becomes really easy when you start joining the dots. Convex mirror, concave mirror. Convex lens, concave lens. Acha, this looks similar to this, or this looks similar to this. Oh, nice, nice. I remember everything. So that's all. Light chapter is not difficult. You just need to correct correlations. You just need to understand it and remember it with nice joinings. Hai na? Nice, what do I say, shortcuts between any these kind of things. Hai na? Correct? Okay, so let's start. Spherical lenses. But you have also studied spherical mirrors. Why they were called spherical? Because that mirror, let's say this concave mirror, kabhi na kabhi, at some point in his life, it was like a part of a sphere. Hai na? Correct? That's why we said it's a spherical mirror. Right? Same thing with convex also. With convex also same thing happened. Zindagi mein kabhi na kabhi, ye ek sphere ka part tha. This was a part of a sphere at some point in his life. That's why this was called as a spherical mirror. Now, what is a lens? Lens is solid thing. Hai na? Lens is solid thing. So we can say it is made up of two spheres. First surface was also a part of some sphere, and second surface, this one, was also a part of some sphere, right? So when two spheres intersected, that was a convex lens, and when this surface and this surface, they were not intersecting, it was a concave lens. Nice. Part of a hollow sphere, you can say it like this, right? Correct? So, and you know, they also look like Venn diagrams a little bit, है ना? This looks like the common portion of Venn diagrams. True, है ना? How many of you remember Venn diagrams in maths? They were quite good, but sometimes difficult question also comes in Venn diagrams, right? Hey, right? That's why. Similar looking like Venn diagrams. So that's why we call them spherical lenses, because they were also at some point in their life a part of a sphere, kind of a part of a sphere, है ना? Nice? True? Okay, fine. So let's come forward. So we have two types of lenses, convex lens and concave lens. Acha, when I was discussing mirrors, I told you there is, at least for me, there was one trick which helped me a lot to understand, sir, concave kaun sa hota hai? Which one is concave? Acha, concave, andar, it is inside, reflecting surfaces like this. Oh, this was a cave. This was a concave mirror. Convex, vex means bulge. Okay, this, yani ki, this was a convex mirror, hai na? Correct? So this is how I used to remember, and I think a lot of you told me that you also remember it like that, hai na? So you know what? The same analogy will work here also. Sir, how? Let me tell you. If you look at a convex lens, see, when light ray is coming like this, if mirror was like this, we call it a convex mirror. है ना? Light ray is falling on the bulged part. It was a convex mirror. Now what is a convex lens? If you have something like this. Got it? So that's why convex mirror was bulged outwards, and same is a convex lens also, है ना? No, Aksh, it's not actually. Lens ke liye you have to have this kind of a shape. That's why. Oh, nice. Thank you, Niva. है ना? So that's why. है ना? Easy, है ना? So that's why I'm just giving this trick to you so that you understand. Oh, that's why it is called a convex lens, and same with convex mirror also. ठीक है? And if you want to define it, see, convex lens is a lens which is thicker in the middle and thinner in the edges. Same thing. बीच से मोटा है ना, corner से पतला है. It is thicker in the middle and thinner in the edges. So normally what happens, students used to remember convex में thicker in the middle, thinner in the edges. I'm saying if you know convex mirror, you know convex lens also. Don't be confused. It's easy, है ना? ठीक है? Same thing with concave lens. Concave mirror कैसा होता है? ऐसा. This is concave mirror. Light comes like this and falls. If you make it like this, it's a concave lens. Simple, right? Simple, है ना? It's not difficult. Very good. That's why. Correct. So these are things to remember. And concave lens, if you want to tell that what is a concave lens, it is a lens which is thinner in the middle and thicker on the edges. Correct? है ना? So I'm saying it is thinner in the middle, बीच से पतला है, and thicker on the edges. Edges से मोटा है. Right? Okay? Fine. Easy. Remember? अब भूलोगे तो नहीं कभी. You won't forget this. Nice. Yes, Tarkar. Actually, refraction is the key. It's happening through lenses. That's why they are bending. Yes, don't worry. I'll make it understand to you. Okay, got it? Nice. So let's talk about special points, because special points were there in mirrors also, right? And similar, it's same. Now that we have started our learning that in mirrors, we normally talk about one side, right? है ना? भाई mirror के अंदर, inside the mirror, you can't go inside the mirror. No, image forms inside mirror, okay. But here, if you take a lens, you can go on both sides. But I can bring my hand here also, I can bring my hand here also. So that's why in lenses, you draw a principal axis, correct? This is a principal axis, and you draw different points. Here, O, the center. What was the center of mirror called? Can someone tell me? Hey, Shivi. So, Shivi, I'm saying convex lenses, thicker in the middle, thinner on the edges. Concave lenses, thinner in the middle and thicker on the edges. है ना? Getting this? Fine. Pole. Nice. Refracting, Mitraj. Refracting surface. यहाँ पर reflection की बात हम नहीं करेंगे. Partial होता है, but it's okay. We'll talk about refraction. Right? It was, yes, Rishi. Biconvex lens में, I'm telling you, biconvex and biconcave. I'll come to that, don't worry, है ना? So O is the optical center. In mirror we used to call it pole. बस यहाँ पे छोटा सा difference है ना? We call it the center of mirror we used to call pole. यहाँ पर center of lens we call it optical center. बस O से लिख देते हैं इसको. Correct? F is focus. We all know. F is focus and 2F is center of curvature. Now, I'm coming to this one very important point. See, 2F, right? 2F and F. I can say F and 2F. In mirrors, we usually say that, you know what? Radius of curvature, right? Radius of curvature is equal to 2F, right? This was our radius of curvature in mirrors. But here also it is true. There is one condition. What condition? C. What is C? Muskan, what is C? Okay, how to prove the C? So C equals 2F will only hold true if your lens is a biconvex. Sir, what is a biconvex? Means it is made by intersection of two equal spheres. If this is your lens and both the spheres are same, then I can say that this is 2F1 and this is F1. Okay, fine, got it. So that's why you can understand it. If both the spheres are equal, तब ये condition hold true करेगा. But I'm saying in your class, in your grade, it's there. They won't go into if it is a plano-convex lens or concavo-convex lens. So these kind of things are not there in your syllabus right now. It will come in 11th. But I'm just letting you know. I'm giving you idea what to unlearn in future. है ना? Fine. So don't worry. Acha, don't be confused with this. C, what is C? Center of curvature you are saying. Huh? See, in mirror, center of curvature was what? This was the whole sphere. This was the center of sphere. It was the center of curvature. And this point was focus in mirrors. Same thing is here, right? Correct? So that's why I'm saying if your lens is made of, so you understood, right? In the starting, it is made of intersection of two spheres. I'll tell about one only. If both the spheres are same, equal, then 2F will be equal to F. Sorry, F twice of focus will be equal to center of curvature. Then only it will be true. Is it? Are you still confused? Just इतना याद रखो, देखो दोनों sphere अगर equal है, if both the spheres are equal, and then if the lens is formed, it means now center of curvature will be equal to twice of F. But in your grade, ये hold करेगा because in your syllabus biconvex lenses are there. Okay, got it? Fine. Correct. I'm coming to this. So on the left side you have F1 and 2F1. On right side we say this is F2 and 2F2. है ना? Understand it like this, 2F2 and F2. So for safe side we are saying it. Okay, got it? Nice, nice. All right. Clear? Yes, two C's are there. That's true. There are two C's. So याद करने का तरीका, how to remember this thing? So this is something which I told you just for the safe side. See, I have told you not the very complete thing, but still just to make you understand. Okay, यहाँ पर भी there is a center of curvature. It is equal to twice the focal length, right? So 2F1, F1, F2, 2F2. Fine. On the right side, we are calling it as focus 2 because how will you differentiate? Left side वाला F है कि right side वाला F है? How will you differentiate? So I am saying left वाला we call it F1, right वाला we call it F2. Simple, है ना? And this is 2F1 and 2F2. Simple. Same thing with concave lens. F1, 2F1 on the left side. F2, 2F2 on the right side. F is focus, 2F is center of curvature. Fine. Okay. Nice. Rishi, there is, but you know what? If I go into that right now, although it's not there in your syllabus, but if you want to understand, no, in BYJU'S app, you can go ahead and there is a whole derivation about this. Don't worry. है ना? Yes, for distinguishing, I'm saying. Nice. You can say 2F, 2F dash also. That's your call. All right. Acha, how many of you have tried this thing? This thing? When we were kids and somehow, luckily, if I or someone finds this magnifying glass na, the first thing we used to do was bhage jate the. You take a paper and you in the sun, you start doing this. Arey jal gaya. Arey छेद हो गया ना, these kind of things used to happen when we were small. So that's why you have tried it, na? It's very nice actually, fun, because when we are children, we like to do these kind of things. You did in your school physics lab, huh? Nice. So why does paper burn when kept in front of a magnifying lens? Because the name says magnifying lens, but it is burning the paper. Why? No, Ishika. I'll come to this question. I understand. It's okay, bache. Convex lenses are converging, right? Correct. Rays converge. Now see, can someone tell me, see in mirrors also we have dealt with this thing. Sun, the rays coming from sun are coming from which position? Sun kahan hai? Where is sun? Nice, Amulu, correct. Tell me, where is sun? Sun is infinity. Sun is very far. In mirrors also we have done. Solar cookers, they used to work on the same principle. They used to take the rays of the sun coming from infinity and they focus at a point called as principal focus. We have learned this, right? Same thing is here only. Sun kahan hai? Bahut dur hai. It's at infinity. So that's why what is happening? When the light rays are coming from the sun, they are like parallel rays and they converge at a point. This point is what we call as focus. Correct? So that's why what you need to understand from here, convex lens is a converging lens. Got it? Convex lens is a converging lens. Same thing with a concave lens. Concave lens is a diverging lens. Now, one thing. See, I'm only giving you some condensed point over here. ये आसान चीज है. This is a converging lens. And in a lot of questions, they will not tell you convex lens or concave lens. They will tell you, in your hand you have a converging lens and there is an object placed at 20 centimeters from the optical center. So they won't tell you convex lens. They will tell you converging or diverging. So this should be very, very interesting and very, very important. है ना? Intersecting inside. Yes. So convex में तो it is actually intersecting like we had in concave mirrors. So do you remember this? In concave mirrors, light ray used to come like this and actually intersect, right? Actually intersect. We called it the real focus. But in convex mirrors, what used to happen? Light ray used to come, parallel ones, and get diverged. But if you trace them back, you say, oh, they appear to meet at a point inside the mirror. We called it focus. It's a virtual focus, right? है ना? It's a vice versa of mirrors. You are right. Same thing is happening here also. In concave, parallel rays came and they got diverged. Are they going to meet now? No, not possible. Why? They are diverging, na? Raste alag alag hain. They can't meet now. But if you trace them back, you get a focus. Now, focus. See, we are talking about focus. Yes. Madhura, it's for both. I'm telling you, it's for both. Very important. So, what do you notice? You will notice that focus of a convex lens is to the right, or I would say to the other side. Correct? Focus of the concave lens is to the left. In mirrors, what happened? In mirrors, focus of concave mirror was to the left. Here, focus of convex mirror was to the right. Now, है ना? मनेंद्र boring नहीं है. आगे question ऐसे आएंगे that you will not be able to solve them. So we should go with basics. अभी boring लग रहा है. I'll see you. It's okay. Questions, let's try afterwards. Yes, it's almost everything opposite in lens that of mirror. Okay, right? So that's why. So people who think that right now it is getting a little boring, I'm saying focus right now. If you understood this clearly, means questions will be easy for you, and I can give you as many difficult questions as I want. And you know what? I don't want you to struggle there. That's why I'm saying. This chapter is very, very important. How do it reminds? Second F, same thing. Where the light rays are meeting, that's the focus. Correct? Nice. When I say focus, which focus do you refer to? I can say the focus of convex lens here is F2. The focus of concave lens here is F1. Simple. You can say that. Because I'm telling you, right and left, why I'm saying is sign convention will also come in this. and I know you are afraid of sign convention also. Right में होगा तो plus होगा, left में होगा तो minus होगा. अच्छा क्या होगा? So we have learned this in mirror also, that this concave mirror focus is negative, it's minus. For convex mirror it is positive to the right. Same thing here. In convex lens it is to the right, the focus will be positive. In concave lens it is to the left, it will be negative. ज़्यादा तो नहीं हो रहा है? ज़्यादा तो नहीं हो रहा है? Let me ask you. I'm giving you a lot of information. I'm telling you. That is the exact reason I asked you. Mirror ढंग से पढ़ा है ना? Yes, correct आस्था. True, है ना? So देवाशीष confusing नहीं है. It's okay. पिछले सेशन और ये सेशन दोनों को मिला के देखना. Everything will be easy. So real focus, yes. F2. Real focus you can say to F2. Right? Fine. ज़्यादा नहीं है. Yeah, Menti will do for numericals. Don't worry. Okay. Now, special rays for convex lenses. See, in mirrors also we had some special rays, ना? अच्छा, कौन सी rays थी special? Can someone remind me? Can someone remind me? In mirrors, what were the special rays? One was. Yes. Niba, correct. That's true. Yes, one was parallel to principal axis, and that used to pass through focus, right? है ना? Okay. Second was passing through center of curvature. It used to go undeviated, right? It used to retrace the path back. Third was pole, correct? है ना? At pole also, incident at pole, right? At focus वाली क्या थी? If it is passing through focus, it goes parallel. All these things we have learned. If you remember all these things, no, you will not struggle with this. Why? Let me tell you. Special rays for convex lens. Why? It's a converging lens. Means a parallel ray after getting refracted from the lens on the other side is going to pass through focus, the F2 point. यही तो है ना? Easy. First one is easy, है ना? Second one, if the ray is passing through focus, after refraction from the convex lens, it is becoming parallel. Same चीज तो है. Convex, concave mirror में क्या होता था? Focus से आती थी, it used to become parallel. यहाँ पर क्या होता था? Parallel आती थी, focus से चली जाती थी. Same thing, है ना? पोल वाला क्या था? ठीक है, पोल वाला बताता हूं मैं. पोल वाला ऐसे था, देखो. यहाँ पोल था, ऐसे आया, ऐसे चला गया. आई. Simple refraction, right? Simple reflection, right? Vice versa. The reason I'm telling you all these cases with mirror is so that you remember. Very important, है ना? Okay. Third one, optical center. Optical center. So this is if a ray passes through optical center. You can say कोई भी ray अगर उस mirror के बीचों बीच से निकलती है, मैं पता कैसे याद रखता था? I used to remember it like if any ray passes through the stomach of the lens. पेट से निकलेगा तो undeviated जाएगा. You can say that, right? It's okay, Anshul, not a problem. Correct? Passing through O means no divergence. It will go undeviated. या तो ऐसे भेज दो या ऐसे भेज दो. It's okay, not a problem. It will go undeviated. Fine, got it, है ना? So the way you want to learn it. I used to remember it कि जो the ray which used to pass through the stomach of the lens, it will go undeviated. Okay, fine. Passes without any deviation. Okay, so if you understood this, let's do a nice interactive question. Okay, let's do a very nice interactive question and let's see if you can answer it. So we'll observe a lot of things. Rishi, correct. I'm telling you, I'm giving you learning now. Unlearning and relearning will happen. Yes, okay, intersecting at O only. Fine, alright, nice. So let's see. Let's try this nice interactive question, and this question is also a part of the BYJU'S app. So if you want to try it, it's there. Okay. Let's start. Come on. Move the candle in front of a convex lens using the slider and observe the image of the candle thus formed. Deviation angle. Sathi, I'll come to this. Not right now, but I'll come to this. If you ask me definition, it's the total deflection from the incident ray. But today I won't talk about this. I'll talk about in this light chapter only. है ना? Yes, Shivi, it's possible. Definitely possible. Okay, right, come on. So at infinity, let's see. When the rays are at, or I would say when the rays are at infinity, see, watch. Rays are infinity and meeting at focus. Okay, meeting at focus, correct? We know this, right? And did you notice these two are still parallel, but they are not like principal axis, one ray upar, one ray niche. It's not like that. It's parallel rays above principal axis, but still they are meeting at focus, means all parallel rays will be meeting at focus. Got it? Fine. Chalo, theek hai. A real inverted and highly diminished image is formed. Acha, what used to happen in concave mirror? When the object was at infinity, what did we get? We used to get highly diminished, real and inverted image. What did we get here? Real, inverted and highly diminished image. Got it? याद आ रहा है कैसे relate करना है? ठीक है? Let's see next one. Beyond 2f. Beyond 2f में you are getting a real, inverted and diminished image between f and 2f on the other side. Yes, Shika, you got the hack actually, right? Real, inverted, diminished. अच्छा, उसके अंदर in concave mirror what used to happen? When the object was beyond center of curvature, we used to get image which is real, inverted and diminished. Where? Between f and c. यहाँ पर क्या हुआ? यहाँ पर क्या हुआ? You got an image which is real, inverted, diminished between f and 2f on the other side. Got it? याद आ रहा है? Can you correlate this thing? See, my whole intention today is to make you understand there is a very good correlation between concave mirror and convex lens. If you understand this, if you crack this, this chapter becomes very easy for you. है ना? Getting it? बहुत easy है? Right? Okay. चलो, at 2f. You can tell me at 2f. Same case as object kept at center of curvature in concave mirror. What do we get? Real, inverted, same size image. Same thing here. A real inverted of the same size formed at 2f. If you keep it at 2f on one side, you will get a real inverted same size image at 2f on the other side. Same thing. है ना? Right? Hey, what's up? Correct? Easy? है ना? Both are same. अच्छा, at f पे क्या होगा? What will happen if you put the object at f? This is easy. What will happen? Image will be nice. Image will be real, inverted and highly enlarged or highly magnified at infinity. Okay, and this question I have answered before also. Sir, both are parallel. How can you say they are meeting at infinity? है ना? आप कैसे बोल सकते हो? How can you say that? I'm telling you. If they are diverging, you cannot say it. But if they are parallel, means you assume that they will meet at infinity. That's why the answer becomes it is meeting at infinity. Got it? Fine. Nice. चलो ठीक है. अच्छा, in concave mirror also, everything was simple. Most special case was when the object was kept between pole and focus. अच्छा, क्या होता था वहाँ पे? When you used to keep the object between pole and focus, what used to happen? Come on, tell me. What used to happen? The image was formed. Image formed was different. It was not real. It was not inverted. It was virtual. It was erect. It was magnified. It was inside the mirror. So यहाँ पर क्या हो रहा है अब तक? Till now, what did you observe? Object you were keeping on the left side. Image was being formed on the right side. है ना? अब उल्टा हो जाएगा. Like convex, like concave mirror. How? Like this. Image formed will be on the same side. है ना? Image formed will be on the same side. Now, yes. The image formed will be on the same side. It will be virtual. It will be erect. It will be magnified. Got it? It will be virtual. It will be erect. It will be magnified. Sir, why virtual erect? देखो, the rays on the right side, they are diverging now. They can never meet. Means if you trace them back, now they will meet. Right? Correct? So that's why the answer is virtual, erect and magnified. In case of lens, R is 2f, chota bheem, right? Okay, so it is on the same side, right? Got it? So it is exactly same as, I would say, remembering wise, it is exactly same as concave mirror. कुछ बहुत difference नहीं है, है ना? Easy है. अच्छा, there is one caution I want to tell you, because today you might not ask this question to me, but tomorrow when you read the books, you might ask this question. Sir, if I keep object between focus and optical center, you are telling me the image will be on the same side. But will it be between f and 2f, or will it be between beyond 2f? और कहाँ, मतलब where will it be there? है ना? Today you might not ask this question, but on your behalf I am asking this question. Where will this image be? Can I say confidently it will be beyond f and 2f, or it will be beyond 2f? Can I say that? Amazing artist, I won't say inside mirror, I would say on the same side of the object. है ना? अच्छा, you are asking now, huh? Beyond C. नहीं जादू नहीं है ये. Between f and 2f. Okay, see. I'll tell you the correct answer now. है ना? Without any jokes, I'll tell you the correct answer. The thing is, between f and o, when you move the object, your image could be anywhere. If you bring the object closer to o, image क्या होगा? So this is an extra information, by the way. No one will ask this to you. If you bring the object closer to o, image इस तरफ आता जाएगा. When you bring your object near f, image पीछे जाता जाएगा, है ना? Image will keep on going away and it will keep on becoming बड़ा. So there is, you can't tell. Image will be between f and 2f or beyond 2f. But there is one thing which you can say with very much confidence. Image कहीं भी होगा, it will be far, or it will be beyond the object. अगर object यहाँ है, image यहाँ होगा. अगर object यहाँ है, right, तो image यहाँ होगा. अगर object यहाँ है, image यहाँ होगा. कुछ भी हो सकता है, लेकिन image हमेशा object से इस side में होगा, on the left side of the object. ठीक है? Ishika, you need justification. The easiest justification I would say is taking a numerical and changing the object position. You will get different V's and you will understand. I'm telling you, that's easy. है ना? So that's why what I'm saying right now is कि don't think where will the image position be, but one thing you can say, it will be on the same side and it will be to the left of object. Fine, got it? Okay. See, I'm telling you these extra things also, by the way, ताकि you should not be confused in future. ठीक है? हाँ, इस तरफ object से तो आगे ही होगा. Got it? Nice. So if you understood this, let's try and solving this question. मुस्कान, उस पे तो एक अलग सेशन करेंगे ना, है ना? Find the properties of the image when a candle is placed between F and O. अच्छा, this is easy, no? Come on, can you tell this? Yes. Yes, Anukriti. Ishika, very good, and a lot of numericals can be asked from this. People are saying A and D, huh? Is it? A or D? A. Real invert. ये कैसे बोल रहा है? Right. Between F and O, special case means virtual, erect and magnified. That is the correct answer. Simple, है ना? Easy. Got it? Okay, let's get back to the session now. Come on. Yes. So these are the different cases we have studied. Okay. And don't worry, I'll give you the notes, right? I'll give you a PDF for this session. You will have this with you, है ना? Don't worry about this, है ना? ठीक है. अच्छा, if you learn all these things, now can you tell me, in that projector wala video, the experiment, the science project session which we did, in this, there was a lens and you told me it was a convex lens. Which case was it? Come on. This question is actually connecting the theory with practical. Come on. Convex lens to tha, but which case of convex lenses I'm asking you? Which case? At C, close but not correct. At F, close but not correct. नहीं, सारे बोल दोगे तो एक तो सही हो ही जाएगा. It was, no, not at F, not at F. not at F. See, F में क्या होता है ना? You need a very very strong light source. हाँ, between C and F. Yes, between C and F. Why? I'll tell you. Do you remember? In this, the object was, I was putting the slide inverted, and then you were able to see the erect diya, right? That was the thing. So what I'm doing is, the case is actually, I was putting the object between F and 2F, and I was getting a real inverted and magnified image, right? And I don't know, someone was asking me, sir, can we keep an object inverted and get an erect image? You know what? That is what we did in this, right? I actually kept the object inverted and I got the image erect. That's how it happened, right? Correct? That's why this is the correct answer. Fine. Between F and 2F. Yes. No. Not between F and O. Between F and 2F. Okay. Got it? So the thing which you are saying between F and O, that is actually magnifying glass. How do we see a magnifying glass? How do we see it? This is actually that case between F and O, or this is not P, this is O. So in this what happens? Same thing. You get a virtual image, a erect image, and a magnified image. Got it? Yes, correct. So this is the case of magnifying glass. All right. So this is, again, I won't spend time on this. See, I won't say you cram it, but you know what? I will say, please understand. I'm not saying to you to remember concave mirror table separately, convex mirror table separately, concave lens mirror separately. I'm saying correlate them. That's how you will gain knowledge. That's how you will feel confident. Okay? So, special rays for concave lens, simple. Like convex mirror, same concave lens. Always virtual, erect, diminished. That's it. और कुछ है ही नहीं इसमें. Virtual, erect and diminished every time. These are the special rays, right? Image formation will be virtual, erect and diminished, है ना? Correct? सब कुछ same है. Mirror याद है तो ये भी याद है. कोई दिक्कत नहीं. Wherever you put the object, doesn't matter. You will always get a virtual, erect and diminished image. Simple, right? हाँ, correct? Easy table, एकदम easy table. Exactly similar to the convex mirror. Same. It's a diverging thing. So ठीक है, चलो एक poll question कर लो. One poll question for you. Come on. I'll give you only two options are there, A and B. There is not four options, only two options. ठीक है? What is the nature of lens that is shown by the rectangular box? A and B options are there. I'll give you 30 seconds. ठीक है? Ready? Position of image, Debashish. It's again object, image in between that, like we had there. Your time starts now. Come on. Let's see. Everyone will give correct answer. I'm pretty sure. Okay. Yes. The correct answer is, because the rays are diverging, it's a concave lens, right? It's a concave lens. True. Easy, है ना? There's no doubt in this. So yes, it's a diverging lens. It's a concave lens. Everybody gave A. Very good. Now, uses of lenses. All these things, we use lenses actually in telescopes, in magnifying glass, in spectacles. In your eye, there is a lens. In cameras, right? All the contact lenses, all these are lenses. We use them every day actually, if I tell you, right? So, to summarize, we have learned this, right? We have learned image formation by concave lens also. Yes, Ishika, correct. Acha, theek hai. There is a homework question. I want to give it to you, and you only told me you want questions in which you have to do something, hai na? Let me ask you, how many of you are wearing spectacles? Haha, Niva, I'll come to this question in human eye. Don't worry. Thank you, Sarthak. Right? Okay. Right? Acha, can you tell me, when you go for an eye checkup, at least if you are not wearing, at least you have seen people, right, who wear, you might have friends, in your family you might have people. So whenever you ask them, अरे आपका number कितना है? What is your eye power? They end up saying some number with some sign also, है ना? Do you remember this? Right? Do you remember this? They tell you some number, right? So you said -2, correct? Someone also said -2, someone said +2, है ना? Today you got, oh, okay. So I got my specs, my first specs in class 11th actually. Plus minus sign, है ना? So the reason I asked this question you, because this is the homework question. Take a screenshot, come on, quickly, we don't have time. अगला session जाना है भाई, जल्दी करो. Take a screenshot. And anyways, I'll give you this session also in PDF. Take the screenshot, come on, right? I want answers, by the way, in the comment section. Okay? ऐसा खाली नहीं होना चाहिए. Alright, so that's why we have got you covered. सब हो रहा है, सब अच्छे से हो रहा है. We'll cover everything, we'll finish everything. Don't you worry about that, okay? Next session will be on lens formula, magnification and power of lens. The reason I gave you this question is because in next session there is about power of lens, right? Nice, very good. So 6 p.m. on Wednesday we have this session, okay? Oh, it's okay, Shikha, don't worry. Okay, all right. Now, guys, very important, Telegram channel. I'll give you all the notes in this session. Nice, okay? And by the way, this is something which you all know. You can try it. If you like, you can buy it. Fine, all right? So, trial class is okay. Last but not the least, like, share and subscribe, because I am seeing class 9th 10th students में थोड़ा ना activeness थोड़ा सा कम लग रहा है मेरे को आजकल. So I'm saying this is a very important chapter. Be active, guys. थोड़ा मेरे को motivation आएगा यार. Come on, है ना? So be active. Make sure you share it with your friends. लालच मत करना. खुद रखेंगे सारा knowledge. Don't do that. Share it. And you know what? Next class is on Wednesday. Okay. All right. So thank you for joining, guys. And you know what? Love you and see you in the next session. Bye bye.